Many people have told me that my 14 kilowatt hour RV power system is overkill. And for many camping situations, they may be right. My primary system is designed so I can stay off-grid for a week or more, but today I'm going to show you a much simpler Renogy-based setup that provides enough power for a typical weekend off-grid. This system isn't complex, even though it's using some of the latest battery technology. It's actually a very basic setup, but it's still fully functional. It automatically charges the batteries whenever the RV is connected to shore power and automatically powers the RV when shore power is removed. So let's install the system and see what a realistic weekend-capable RV electrical system actually looks like. Here you can see the first battery in place, and look how small it is. Now here is where I placed the second battery. Here is the REGO 3000 watt inverter charger. Then I added the 400 amp fuse, followed by the battery disconnect switch. And finally, I completed connecting the wiring. One advantage of modular RV electrical systems is the ability to reconfigure depending on how you plan to camp. Today, I'm temporarily removing my primary system and installing a compact Renogy-based setup designed around simplicity and reliability. This setup uses two Renogy 12.8 volt 240 amp hour semi-solid state batteries connected in parallel, paired with the Renogy REGO 3000 watt inverter charger. Now, I'll mention up front, this installation isn't optimized for space. I intentionally laid everything out more openly so you can see clearly how it's all wired. In a permanent install, I would tighten this up and reduce cable length, but for demonstration purposes, visibility is more important. I'm using a 400 amp Class T fuse, which is what Renogy recommends for this inverter size. Notice the Class T fuse is installed as close to the battery as possible. In high current lithium systems, the goal is to protect the cable itself, not just the equipment. Before we continue, it's worth explaining what makes these batteries different, because their main claim to fame is the semi-solid state technology. Most RV lithium batteries today use a liquid electrolyte inside the cells. That liquid allows energy to move between the electrodes, and it's the technology that has powered most RV lithium systems for years. At the other end of the spectrum are fully solid-state batteries, which replace that liquid entirely with a solid material. Solid-state batteries promise very high safety and stability, but they're still emerging technology and not widely available for RV applications. These Renogy batteries use a semi-solid state design, a stabilized electrolyte structure with reduced liquid content, improving thermal stability and structural durability while still delivering lithium performance. In practical RV use, the battery has advanced BMS temperature protection, is IP67 rated, has self-heating, and is smaller and lighter than traditional lithium batteries. So while this system is intentionally simple, the battery technology itself represents one of the newer developments in RV energy storage. Of course, batteries are only part of the system. The device that makes this fully functional is the inverter charger. An inverter converts 12-volt battery power into standard 120-volt AC power, the same type of power your RV uses to run appliances like the air conditioner, microwave, and outlets. A charger does the opposite. It takes incoming 120-volt shore power and converts it back into 12-volt DC power to recharge the batteries. When you combine those two functions into a single unit, you get an inverter charger. What makes this especially useful in an RV is the built-in transfer switch and pass-through capability. When shore power or generator power is available, the inverter automatically passes that power through to the RV while simultaneously charging the batteries. When shore power is removed, it instantly switches to battery power without any manual intervention. So even though this setup is basic in architecture, the inverter charger makes it fully automatic and seamless. I'm using the 30 amp outlet in the rear garage area that's connected to the RV's transfer switch. That outlet feeds the AC input of the REGO inverter. When shore or generator power is available, the inverter operates in pass-through mode, powering the RV while charging the batteries. When shore power is removed, the inverter automatically switches to battery operation. Now, quick note, in this video I'm showing how I set this up in my own RV, not providing a professional installation guide. So always follow manufacturer wiring specifications and consult qualified technicians before modifying any electrical systems. We're now completely off-grid, so no shore power, no generator, just the Renogy battery bank and inverter. This is the exact scenario this system is designed for, realistic weekend camping. To start, I'm going to turn on the rooftop air conditioner. So in most RVs, the AC is the single largest load. Let's turn it on. If a system can comfortably handle the AC, it can usually handle everything else. At this load, we're pulling roughly around 100 amps from the battery bank. Very manageable for a simple 12-volt system like this. Now, let's add something practical. I'm using the Turbro electric griddle model EG13, and this is a great match for a B-class van. It's compact, easy to store, and it comes with its own suitcase-style carrying case. It runs between 350 and 850 watts, heats up to 465 degrees Fahrenheit in just about 2.5 minutes, and features a food-grade ceramic non-stick surface for easy cleanup. Right now, we are drawing approximately 970 watts. This is exactly the type of real-world cooking load you'd expect on a weekend trip without starting a generator. If we run both the air conditioner and the griddle at the same time, we get a realistic cooling and cooking scenario. So now we're pulling roughly over 2,000 watts. This is still within the operating range of this inverter and battery bank. My main system is designed for week-long off-grid stays. This system is designed for realistic weekend autonomy. So you don't need a week-long system to enjoy a weekend off-grid. You just need enough capacity for the loads you actually use. If you'd like more information about the Renogy components or the Turbro EG13 griddle, I've placed links and any available discount codes in the video description below. So if you found this video helpful, don't forget to like and subscribe for more real-world RV power builds and testing. Thanks so much for watching, and as always, stay charged!